Greetings and welcome, friends. Mr. Waddy here, hanging out with my geometry buddies. We are talking about question 9. I think we were talking about, was it the topic? It was about segments and probably measuring and constructing them, maybe? And then, midpoint, I think, happened in there. Bisector was defined. All sorts of great things. Let's find out what happens. It says, identify the segment bisector of segment XY, and then find XY, and this XY is not referring to the picture, the diagram, but a number representing its length, the distance between point X and Y. So first of all, a segment bisector, you could have said is, I'll call that, where's my colors at? Here we go. I'll call that part A of the problem. I could define M as a segment bisector. I could have said MN, the ray, is a segment bisector. I could have said MN, the segment. I could have said MN, the line, even though the line is not drawn as continuing. But yeah, all of those are types of segment bisectors. I'm assuming they were probably just looking for the ray. Which, by the way, remember that ray NM is not the same as ray MN, because that would be the ray that starts at N and then travels through M. So part B, this looks like some good old algebra showing up here. Now, if that is a segment bisector, I know because these two segments are labeled congruent, and therefore these segments are congruent, and these two segments are equal to each other, XM and MY, and then their measures are equal by def of Kong. So I'm going to say 3x plus 1 equals 8x minus 24. Let's see. Let's just algebra. Just color. Look at the colors. Just steps showing up. Negative 5x plus 1 equals 4. Beautiful. Minus 1. Oh, it's even going to be divisible by 5. That's amazing. Nice of them. And you guys are all experts at the solving single variable equation. So I get x equals 5, which is not the answer. They wanted to know the value of xy, which I could actually plug this in for x here and double it. I could plug it in for here and double it. I could plug it in for both of them and add them together using segment addition postulate, right? Let's go for that one. I'm going to say xy equals 3 times 5 plus 1 plus 8 times 5 minus 24. 1656. Is that 42? 32. All right. Thanks for having my back, friends. So that's the length of the entire segment. So yeah, let's keep cruising. All right. Find the coordinates of the midpoint. Midpoint formula, you could imagine as being the average of the x's and the average of the y's. So this problem's not terrible. So let's label this x1, y1, x2, and y2. Plug in what I know and simplify. So point, I guess I'm calling it m in this. So negative 2 plus 4 divided by 2, and 0 plus 9 divided by 2. 2 over 2, 9 halves. My midpoint is 1 and 9 halves, like so. 1/2. Right, call it that. That's fine. So that's not that bad. What's weird is when you know the midpoint and you're looking for the coordinates of the other endpoint, which I think I ended up last week. I referred to as this component as x sub m. That's what it was. And I referred to this component as y sub m. Because for this next problem, I'm going to want to solve endpoint after I already know. So, So this looks like x1 and y1, and then I'll call this x sub m and y sub m. And I'm going to just write two different equations. So for the midpoint x coordinate, going to be the average of 5 and other endpoints coordinate. And 3, the midpoint's y coordinate, should be the average of -6 and the other endpoint's y coordinate yet to be by us. So I end up with kind of two equations, and then I'll solve them. Yeah, I'll just double both sides, clear that fraction. And hey, I might as well do that to both of these equations simultaneously, because it's this. So 8 is going to equal 5 plus x2. 6 is -6 plus y sub 2. Well, I've got this. Subtract 5 from both sides. Over here, I'd add 6 sides. So I'm going to get x2 is equal to 3, and y2 is... so my other endpoint, they give me a name, h. H is the point 3, 12. Yeah? One's a little trickier. Using the formula, which they didn't label with these x, m, and y, m's, kind of backwards. Plug in what you know, solve for what you don't. Tell you what, I'm going to show... We're going to be talking about coordinate planes today anyway. Let me put some Desmos calculator. I just want to show you... you guys use Desmos yet? 5, -6. And 4, 3 is the midpoint. So one of the things you can do is, if graphically you're can actually kind of barely, yeah, I went up to 12. You can kind of almost view this as like a slope formula problem. To go from the red point, so the blue point is a midpoint. So I know that the other endpoint must be on the other end of it somewhere, right, in this region, in order for the midpoint to be mid. So I actually just think of, how do I go from this red point to that blue point? Well, I'm going up. Looks like. And backwards 1. Did I do that 9 right? Backwards 1. And if I want to find the other point, I can just repeat that pattern. If I go up 9, backwards 1, that should actually give me my other end. Kind of an interesting graphical. Now, if your kind of slope, quote unquote, that we're doing was something that could reduce, you wouldn't reduce it. Okay? Because imagine if I was going like up 4 and over 2, right? Just arbitrary. I wouldn't be like, oh, 4 divided by 2 is 2, so I want to go up 2 and over 1. That's the other endpoint. That would be false, because I've reduced it. And it would land on my segment, but it wouldn't be the other endpoint, right? Because I'd have to go. So anyways, so that's a side note. And then, find the distance between 2 points. Distance formula is a cousin of the Pythagorean theorem. Oh, was it? All right. Well, you guys follow along and be good. Good. So let's see. And you guys have done distance before, I believe. Yeah. So let's see. Distance, which I can just refer to as AB now, since that's the point, is going to be, the square root of 7 minus all squared plus 10 minus 2. I was just confused for a minute. I was wondering why my writing has been like thicker than usual, and then I realized it's because my tablet is plugged in and charging. Oh yeah, because it does this weird thing. Watch, if I unplug it, There we go. Now when I write, I'll actually have variation of thickness. That's all right. It's too late for this video. There you go, friends. 7 minus 3 is 13. 7 minus 13, as we call it sometimes. What's that? That sounds like a -6. And plus 10 minus 2 is ocho of the positive variety. And the good thing about these squares is that they become positive numbers anyway. Oh, what? No, you didn't. What? Square to hundo? 10. There you go. Distance formula. And I think the homework. Well, anyways, thanks for watching, internet friends.